it's quite a big area, so there is quite a lot of information to cover, but I think we'll try and get through it as quickly and painlessly as possible. So, right, we took care of the environmental part of the ECPA Reaching project, along with working very closely with colleagues from some of the ECPA member companies as well, which was very useful in this project. So I'm going to talk about the first part of the work, which was phase 1. This is really just a recap. So I'll talk about the phase 1 objectives, the applicability of the 91414 assessments. This is really what we're interested in, seeing whether or not 91414 assessment schemes cover co-formulants. I'll look at the terrestrial and the aquatic areas and also consider the other compartments. Then we're also asked to look at what other industries are doing with regard to assessments under REACH, and I will introduce the concepts of ERCs and SPERCs to you. Some will probably be very familiar with this, some perhaps less so, before concluding on phase 1. Okay, so the phase 1 objectives were to identify the relevant environmental exposure pathways for co-formulants included in crop protection products, and then to evaluate the extent to which the existing assessment schemes that apply for plant protection products, and specifically the Annex 3, which covers the product itself, would actually cover the co-formulants included in products. Then we wanted to identify the data and the endpoints that would be available to suppliers, so that if any approaches that were developed would be able to be used with the data set that would be available, basically. Then we were asked to consider the approaches that were being developed by other industries, and then if we felt that there are any methodologies were required, we should assess the suitability of existing methodologies, for example, those that are already existing under REACH, or 91414, e-uses, etc., for demonstrating co-formulant safety, and then, of course, make recommendations as to how we could develop or apply those models at phase 2, which we'll move on to. So, a brief summary then of the exposure pathways that we considered. Clearly, if you apply a spray, then you've got a potential for volatile emission to air. Obviously, you're going to have direct emission to soil with a plant protection product. There is a risk of exposure to surface water, as well as a potential risk of leaching to groundwater. Also, there is potentially a risk of exposure to humans who would be consuming environmental media, drinking water, crops, meat or milk, etc. And then finally, you could also get exposure via the food chain to predators, known as secondary poisoning. So the first task then really was to evaluate how the 91414 assessment schemes could, whether or not they cover the co-formulants that are contained within plant protection products. So Annex 3 of the 91414 directive sets out the data requirements for the authorization of plant protection products at the member state level. These requirements include specific assessment of the potential for environmental impact of the formulated products where relevant. And essentially this is to account for the possibility that the formulation might be more toxic than the technical active substance. So I guess the key conclusion here is the intention of 91414, the assessment scheme that's applied, is that it is intending to take account of co-formulants that are included within the products themselves. So now I'm going to go on and look more specifically at individual exposure pathways. So first we're looking at the direct exposure to soil. Now, the initial soil exposure will be to the formulation. And indeed, applications for product authorization under 91414 actually must consider the potential impact of the formulated plant protection product on the terrestrial species that would live within the soil. And so when they carry out the assessment for this, it's often necessary to actually carry out studies with the formulated product itself. So as the co-formulants are included within the product, then the assessment of the risk characterization will intrinsically take account of those co-formulants that are included in the products that are tested. So our first conclusion really here is that 91414 assessments effectively cover this exposure pathway. So I'm going to run through a little example of how you'd carry out an assessment for a product under 91414, just to give you an idea of how the co-formulants are taken into account. So this example here, we've got a product applied at 0.8 kilograms per hectare, and we've got 10% active substance in it. So that means you get an application rate of the active, and then taking account of a standard parameters of bulk density and mixing depth, you get a peck in soil. Now this is always expressed, well, in this case is expressed as mgs per kg soil of active substance, but in some cases they will also calculate the initial peck based on the product itself. And then, of course, a plateau peck in soil will be calculated, although this isn't actually relevant for co-formulants because that will be dependent upon the soil degradation rate of the active substance rather than the co-formulants. And hence, the different fates will result in different plateau pecks. So, something that will be familiar to a lot of you here, I think. This is the TER calculation, which is very similar to the one that's carried out under REACH, except under REACH they have the calculation the other way around and they call it an RCR. But it's all the same thing, just different ways of expressing it. In this case, for a TER, take your effect endpoint, divide it by your predicted environmental concentration, and then look at the resulting TER. If it's greater than a trigger value, then that gives you an acceptable risk. If it's less than the trigger value, you have an unacceptable risk. Which is kind of converse, really, what we're trying to do in REACH. We're all trying to get all of our RCRs below 1. A trigger value is the equivalent to an assessment factor under REACH. So this example risk characterization here, you can see that this active substance is tested as an acute endpoint in the top row here, which is an LC50, 16 mg per kg AS of soil, and the TER was calculated there, but that's not relevant for our use because that's just the active substance. Below that, you can see that a risk characterization has also been carried out for the formulated product. This is my hypothetical product, Bugkill SC, and you can see here, interestingly, that the endpoint, the LC50, is actually higher than the one for the active substance. And in some cases, this is the case. The co-formulants can actually serve to decrease the apparent toxicity of the actives, which is quite interesting. The resulting TR here is greater than the trigger value of 10, and so this is a safe use. Note that there's also a long-term study here, which is also carried out with the formulation, but this is not really relevant for our use because this, again, this is compared against the plateau peck in soil, and hence is not really reflecting the environmental fate of the co-formulants, rather just the active substance. Okay, so the conclusion from this example is that, as I've demonstrated, acute test data is available for the active substance and for the formulated product. And testing that's conducted using the formulated product reflects the active substance and the co-formulants. So the initial peck in soil is calculated according to the product application rate, and both the exposure and the effects data are converted to active substance concentration in order to perform the risk characterization. But nevertheless, the risk characterization inherently takes account of the substances that are included in that formulated product. So, moving on then. The other key compartment to consider here is aquatic exposure. And again, applications for product authorization under 91414 must consider the potential impact of formulated products on the aquatic species. Again, in order to determine a suitable endpoint, toxicity testing is usually actually carried out with the formulations on algae, Daphnia and fish. And again, the risk characterization that's generated will intrinsically take account of any co-formulants that are included in that product. So again, we've concluded here that the 91414 assessment scheme effectively covers this exposure pathway. And of course, any RMMs that are implemented as part of the product registration assessment, such as, for example, buffer strips to pass the spray drift assessment, will actually therefore also assure the co-formulant safety itself. Having said that formulation testing is always available, it isn't always available. In some cases, testing on the aquatic toxicity of the substance might not be carried out. And this is only in cases where, for example, the TER based on the active indicates more than 100-fold margin of safety. And the implicit assumption here that's applied by the pesticide regulators is that the co-formulants might serve to increase the effect of the active substance, but they're actually unlikely to drive the environmental toxicity of the products themselves. Really, that's going to come from the active substance itself. And looking at this a bit further, an interesting paper by Schmuck et al. Compared active substance toxicity against formulation toxicity for Daphnia algae and fish. And they looked at a large number of pesticides from a range of different formulation types. And for fish and algae, the formulation was less than 5 times more toxic than the active in 98% of the cases. And for Daphnia, that figure is less than 10%. And if you consider this, this trigger of 100-fold safety, then it's fair to assume here that if formulation testing is not required under 91414 Annex 3, then this is because the co-formulants would not be expected to significantly contribute to the overall toxicity of the product. So then, moving on. Other compartments, air and groundwater. Now, the 91414 assessment scheme assesses both the active substance and the relevant metabolites, and it takes account of all the relevant information that's available on the product and the active substance. And it generally uses quite complex models to estimate the PEC, the predicted environmental concentration, for the active substance only. And really it's assumed that the co-formulants will not impact on the overall assessment. Therefore, strictly speaking, groundwater and air are not really covered by the 91414 assessment scheme. However, under REACH, direct assessment for these compartments is not actually required, but rather under REACH, these compartments merely form an overall exposure to humans via the environment. So our argument here is that specific assessment for air and groundwater is not required, but this is inherently taken into account in the assessment scheme for humans via the environment. Moving on.